And here's number 30. It's log of 3x plus 1 equals 1. And we know the log is actually log base 10. So let's go ahead and convert this to an exponent. And that would be 10 to the first is equal to 3x plus 1. Well, 10 to the first is just 10. And then we can subtract 1 from both sides and then divide by 3. So x is equal to 3. For number 31, first we want to divide by 9 on both sides to get the log by itself. And that would give us log base 4 of 2x is equal to 3. And then let's convert this into an exponent. So that would be 4 to the third power equals 2x. Now let's divide by 2 on both sides. Well, actually 4 to the third is going to be 64 first. And then let's divide by 2. So x is going to be 32. And then number 32. So we have log of x plus log of x minus 3 is equal to 1. The addition of the two logs can convert to multiplication. That will condense to multiplication, so that will be log of x times x minus 3 equals 1. Distributing the x, we get log of x squared minus 3x equals 1. Now we can convert this to an exponent. We know the base is 10, so that would be 10 to the first power equals x squared minus 3x. Well, 10 to the first is just 10. And now we have a quadratic, so we'll need to set it equal to 0 on one side. So let's subtract 10 from both sides. So we have x squared minus 3x minus 10 equals 0. And now this can be factored. That would factor into x minus 5 times x plus 2 equals 0. Then we need to set each one of these equal to 0 and solve. So when we solve the x minus 5, we get 5. And when we solve x plus 2 equals 0, we get negative 2. So it appears that we have two answers, except we really only have one, and that is because you cannot take the log of a negative number. And so in the original problem, we have log of x. And that cannot be a negative number. All right, the log of a negative number is undefined. So that means that x cannot be 2, or negative 2, sorry. X cannot be negative 2, and therefore x is only 5. And here's number 33. So we have log base 5 of x plus 4 plus log base 5 of x minus 3. Well, we can use the product rule. Addition turns into the product. So that means that this would be log base 5 of x plus 4 times x minus 3 equals log base 5 of x squared minus 7. All right, now we can multiply the x plus 4 times x minus 3, and that's going to give us x squared plus x minus 12. Now we have log base 5 of something equals log base 5 of something else. So now we can drop the logs. So x squared minus, or plus x minus 12 equals x squared minus 7. If we subtract x squared from both sides, those x squareds would cancel out on both sides. Then we would have x minus 12 equals negative 7. Adding 12 to both sides, we get x equals 5. And here's number 34. Again, we have the addition of two logs, so that will condense into a product. So that would be log of x minus 2 times 2x plus 6 equals 2. Now we can go ahead and convert this by multiplying out these two binomials. When we distribute it out, you'll get 2x squared plus 2x minus 12. Well, let's go ahead and convert this into an exponent. We know log is actually log base 10, so that would be base 10 raised to the second power equals what you have on the left side. Now 10 to the second power is 100. And because it's a quadratic, we want to set this equal to 0. So let's subtract 100 from both sides. And we get 2x squared plus 12x minus 112 equals 0. Now we can divide everything by 2. And we have x squared plus x minus 56 equals 0. And this can be factored. That factors to x plus 8 times x minus 7. We're setting that equal to 0. So if x plus 8 is 0 or x minus 7 equals 0, then we have two possible answers. We have x is negative 8 and x is 7. But we're going to have to cross out the negative 8, and that's because when you substitute negative 8 into the original, you end up taking the log of a negative number. Because negative 8 minus 2 would be negative 10, and the log of negative 10 is undefined. So we end up crossing out the negative 8 as a potential answer, so the only answer we have is x equals 7. Alright, for 35 we have log base 3 of 5x plus 6 is equal to 4. Converting that to an exponent, it's 5x plus 6 is equal to 3 to the 4th power, and 3 to the 4th power is 81. Let's subtract 6 from both sides, and then divide by 5. And so x is 15. And here's number 36. Let's go ahead and use the exponent rule in reverse. So this 3 will become the exponent of the 4. This 4 will become the exponent of the 3. And the 2 will become the exponent of x. So rewriting all of that would be log base 2 of 4 to the 3rd plus log base 2 of 3 to the 4th minus log base 2 of x squared equals log base 2 of 6 squared. Oh yes, the 2 here becomes the exponent of 6 as well. Alright, 4 to the 3rd is 81. 4 to the 3rd is 64. 3 to the 4th is 81. That still remains as x squared, and 6 squared is 36. So this is everything rewritten. Now this addition will condense to multiplication, and then this minus will condense to division. So we'll end up with 64 times the 81, because that's a plus in between there, and then you'll have an x squared on the bottom of the fraction because of the minus. So that's what we have here, log base 2 of 64 times the 81 all over x squared equals log base 2 of 36. Now next we can multiply the 64 times 81 to get 5184. Now we have log base 2 of something equals log base 2 of something else. So let's drop the logs off. And now we have 5184 over x squared is equal to 36. Well, let's multiply by x squared on both sides. So we have 36 times x squared here. And then let's divide by 36 on both sides. And 5184 divided by 36 is 144. So x squared is 144. Let's take the square root of both sides to get x is equal to plus or minus 12. Now, we know that we cannot take the log of a negative number because it's undefined. So this negative 12 option is not really an option. So we have to get rid of the negative 12 because log base 2 of negative 12 is undefined. So only one solution is valid, and that is x is equal to 12. Alright, here's number 37. We have log base 5 of 5 to the 11th equals x plus 7. Now there's actually two methods that we can use. The first method is I'm just going to convert to an exponential right away. So that means this base of 5 will be raised to the power of x plus 7, to equal 5 to the 11th. So that's it. 5 to the x plus 7 equals 5 to the 11th. And we have the same base, so let's drop the bases out. 11 equals x plus 7, and subtract 7 from both sides, so x is 4. Now, method number 2 is we can use a rule where the base of the log is the same as the base of the exponent. Then they just cancel each other out, and you're just left with x. So log base b of b to the x is just x. And using that rule, log base 5 of 5 to the 11th would just be 11. So we would have 11 equals x plus 7, then subtracting 7 from both sides, we get x equals 4. So either method 1 or method 2 will work. Then for number 38, I recognize that we can have the same base on both sides, and that base would be 2. 16 is 2 to the 4th, and square root of 2 is 2 to the 1/2. So we have 2 to the 4th raised to the x, and 2 to the 1/2. Then we would multiply the 4 times x, which is 4x, equals 1/2. The bases drop out. And then let's divide by 4 on both sides, and so we end up with x is equal to 1/8. And here's number 39. We have log base 5 of 2 plus 2 log base 5 of x equals log base 5 of 3 minus x. Well, let's take this 2 and move it into the exponent position. So that'll be log base 5 of x squared here. So this is what we would have on the next line. All right, now this addition, the adding of these two logs will convert to the product. So on the next line, that'll be log base 5 of 2 times the x squared equals log base 5 of 3 minus x. Now we can drop the logs out and just set 2x squared equal to 3 minus x. Since this is quadratic, we'll move everything to the left side and set it equal to 0. So 2x squared plus x minus 3 equals 0. And now we will factor that. If we multiply the 2 times negative 3, we would get negative 6. And what would multiply to negative 6 would also add up to positive 1. That would be positive 3 and negative 2. So factor by grouping, we would have 2x squared plus 3x plus negative 2x minus 3. Now let's go ahead and factor out the x from the first group and also factor out a negative 1 from the second group. So we have x times 2x plus 3 minus 1 times 2x plus 3. And then the common factor here is 2x plus 3. So now we have 2x plus 3 times x minus 1 equals 0. Setting both of those equal to 0, and then solving, we get x equals negative 3 over 2, and x is equal to 1. However, we have to end up crossing out the negative 3 over 2 because we cannot take the log of a negative number here. So we cross out negative 3 over 2 as an answer, and we only have x equals 1 as an answer. Let's go to number 40. So we have two logs here, but first let's look at the outer log. So we have log base 4 of something equals 0. Let's go ahead and convert that to an exponent. And that would be log base 5 of x equals 4 to the 0. 4 to the 0 is just 1. And now let's convert this to an exponent again. So that would be 5 raised to the 1 equals x. And of course 5 to the 1 is just 5, and that is our solution. All right, now we get into some word problems. Here's number 41. The initial population of a small city was 43,750. The population is decreasing at a rate of 4% per year. when will the population reach 20,000 people? Well, the equation is going to be A, which is the amount of people, equals our initial amount, which is 43,750, times 0.96 raised to the power of t. Now, why is it 0.96 as the base? That's because it's decreasing at a rate of 4%. So you subtract 4% from 100%, leaving you with 96%, which is 0.96 as a decimal. All right, now we want to know when the population will reach 20,000, so we take this equation and set it equal to 20,000. Now let's divide by 43,750 on both sides, and we have this fraction. So 0.96 raised to the power of t is equal to this fraction. Let's convert it into log form, and that would be log base 0.96 of this fraction is equal to t. Now we can put that in the calculator. All right, here's my calculator, and I'm going to do this two ways. First, I'll use the change of base rule. And so the change of base rule says that this is going to equal the log of what's in the parentheses. So let's press the log button and then type in what's in the parentheses, which is the fraction, 20,000 divided by 43,750, close parentheses, and then it's going to be divided by another log of the base, 0.96. So press the log button again and type in 0.96, close parentheses, and let's press enter. And we see that it's going to end up being 19.17 years, 19.17 years. All right, method number 2 is to go into the math menu. So you press the math button, then you go down here where it says log base, and then you type in the base number, which is 0.96, and then type in the fraction that's in the parentheses. So 20,000 divided by 43,750, and press enter, and you get the exact same answer. So our answer is 19.17. All right. That 19.417 is the number of years that it would take to reach 20,000. And for number 42, you want to double an investment in 9 years. If the interest compounds continuously, what interest rate must you earn? All right, so here's our equation. Because it says compounding continuously, we will use the continuous compounding formula. That's A equals P, that's the initial value, times E raised to the power of RT. Now, since we are doubling in 9 years, we don't know how much we are starting with, so we don't know what P is, but we do know that it's doubling in 9 years. So that means we would replace the T with 9 years. So that exponent is just going to become 9 times R. And the amount will double from P to 2 times P. So again, we don't need to know what P is. We don't need to know what we're starting with. We just need to know that it's doubling in 9 years. So the amount we end up with is 2 times P. Now all we have to do is divide by P on both sides, and the P's cancel out, and we get E raised to the 9R equals 2. Let's convert that to natural log. So that's going to be natural log of 2 equals 9R. Now let's divide by 9, and R is natural log of 2 divided by 9. We put that in our calculator, and we get 0.077, which means 7.7%. That would be our interest rate. And here's number 43. What interest rate compounded continuously is required for a $14,000 investment to grow to $16,500 in 5 years? The equation is going to be a equals p times e raised to the rt, because this is the continuous compounding formula. Our initial investment is $14,000, so that is p. Our time is 5 years, so we replace t with 5, and that becomes 5r as the exponent, and we set it equal to 16,500. We will divide by 14,000 on both sides, so e to the 5r is equal to this fraction. We'll then convert it to log form, and that would be the natural log of the fraction is equal to 5r. To get r by itself, we'll divide by 5 on both sides. So r is the natural log of this fraction, all divided by 5. We can type that in easily in our calculator by pressing the natural log button, typing in our fraction, and then dividing by 5. So that's 0.0328. Well, that's going to round to 0.033. So that's what we have here. So r is 0.033, which means it's going to be 3.3%. And here's our last question, number 44. If you invest $3,500 at 5.5% interest compounded monthly, how long will it take for the investment to reach $20,000? Well, because we're compounding monthly, we need the equation that has n. So it's a equals p times 1 plus r divided by n raised to the power of n times t. Now n is the number of times per year that your interest is compounded. And since it is monthly, that's going to be 12 times a year. So n will be 12. P is our initial investment of $3,500. R is our interest rate of 5.5% converted to a decimal, so that would be 0.055. All right, let's put everything in. So that's going to be 3,500 times 1 plus 0.055 over 12 raised to the power of 12t equals 20,000. Now we're solving for t, which is the number of years. Let's divide by 3,500 on both sides. So we have 1 plus 0.055 over 12 raised to the 12t equals this fraction. We can then convert it into log form. So log base 1 plus 0.055 over 12 of this fraction is equal to 12t. Now we just divide by 12 to get t by itself. And so t is going to be log of 1 plus 0.055 over 12 of this fraction, all divided by 12. Now we can put that in our calculator. All right, let's put this in our calculator, and I'm going to do this 2 ways just so we can get the practice. First, I'll do it using the change of base rule. So it's going to be the log of what's in the parentheses first, this 20,000 divided by 3,500. So let's press the log button and then type in this fraction here, 20,000 divided by 3,500, close parentheses, and then it's going to be divided by another log, and that log will be the base, 1 plus 0.055 over 12. So let's type that in, 1 plus 0.055 over 12. We'll close that parentheses, and then all of that is being divided by 12. So that would be pressing the division button again, and then 12. All right, and we get our answer of 31.76 years. Now let's double check it by typing it in the other way, which is going into the math menu, going down to log base, and typing in the base which is this 1 plus 0.055 over 12. All right, got that typed in. Now we'll go inside the parentheses and type in this other fraction. It's 20,000 divided by 3,500. And then we'll jump out of the parentheses, and now we divide all of that by 12. So divide it by 12, and press enter. And yes, we get the exact same answer. So t is 31.76 years. And that concludes this video on the Unit 8 test review solutions.